Welcome to Math Maxtra. This is Sarita. In the yesterday class, we have seen what is transversal line and what are the classification of angles made by a transversal line. In this class, we are going to discuss what are intercepts. The intercepts concept is related to a transversal line. So, we'll now first see the definition of what is intercept. See, you take any two lines. These are the two lines and this is a transversal line. This is a transversal line P and these are the two lines L and M. So this transversal line, if this transversal line meets the lines L and M at A and B respectively. So this transversal line meets the two straight lines L and M at the points A and B respectively. So this AB length, this the line segment AB and this length of the line segment AB, we call it as an intercept made by the lines L and M on the transversal P. So this is how we define an intercept. So a point about intercept. So some points we need to remember while solving the questions in the geometry related to intercepts. See one more point. So these are the two straight lines. These two straight lines making an intercept AB on the transversal P. So if you take three straight lines, what happens? See, you take three straight lines. These are the three straight lines L, M, N. So these are the three straight lines and this is a transversal line P. So here now the these three lines are making an intercepts. So these are this transversal P meeting the straight lines at the points A, B and C respectively. So these A, B, B, C are this AB and BC. These are the intercepts made by these three lines on the transversal P. If these two are equal, if these two intercepts are equal, that is AB is equal to BC. If AB is equal to BC, then you take another transversal on the same straight lines. So you take another straight lines, that is Q. So this is a transversal Q. It is meeting the straight lines in three different points, that is some P, Q, R. So these PQ and Q are the intercepts made by the same lines on different transversal, that is Q. So if these two are equal, then the transversal on the Q, these two intercepts also equal. Then, so if AB is equal to BC, then PQ is equal to QR. If PQ is equal to P, then QR. Okay. And another point about a transversal lines and intercepts. See, you take three lines. These are the three straight lines and this is one transversal line P and this is another transversal line some Q. These are the three lines L, M and N. Yes. So if these two are different, so because the distance between these two parallel lines and these two parallel lines may be different, right? So that is why if this distance some A, B, C, if these two are different of lengths, okay, and these P, Q, R, this PQ intercept length and QR intercept length may be different. But the note point is, if the ratio of AB and BC. So these are the intercepts ratio. These are the intercepts ratio made by the lines LMN on the transversal P. So this AB by BC. This ratio is always equals to the ratio of PQ and QR. This is these PQR, these PQQR intercepts made by the same three straight lines but on different transversal. So this transversal is different, this transversal line is different. These three lines making an intercepts AB and BC on this transversal and PQ and QR on this transversal. The note point is the ratio of AB and BC, which is always equal to PQ and QR. Not only two transversal lines, there may be any number of transversal lines. So you take another transversal, that is T here. So this ratio is again equal to some L M N. So this ratio LM by MN. So you take any number of transversal lines, but the intercepts made by the same three straight lines on different transversal. So the ratio of intercepts are always equal. So this is the note point we have to remember while solving the questions. Okay. So we'll move to the theorem, that is corresponding angles axiom. What is that? Corresponding angles axiom. So corresponding angles axiom. What is the statement? What is the axiom? See, you take two parallel lines. Okay. You consider two parallel lines. This is one line L and this is the another line M. These two are parallel lines. You take one transversal. Okay. You take one transversal. This is the transversal line P. Yes, we know a transversal line makes 8 angles on the two lines. But as these two lines are parallel, so this transversal making different types of angles that we have seen. Angle 1, 2, 3, 4, angle 5, angle 6, angle 7 and angle 8. We know it is forming different type of angles, that is corresponding angles, interior angles, exterior angles, alternate interior angles, so on. So see, if these two lines in the previous video we have seen these two lines may be any type of straight lines, means they may be parallel or they may be intersecting lines. So whatever may be the types of straight lines, we have seen a transversal and the different angles made by the transversal. But in this case we are particularly saying these two lines are parallel. So because of these two lines are parallel, the corresponding angles are equal. The first is corresponding angles are equal. And the second one is alternate angles are equal. And third one is allied angles are supplementary. Allied angles are supplementary. These three are possible only when the two straight lines that we are considering must be parallel. See, if a transversal, meets two parallel lines, if a transversal meets two parallel lines, then the corresponding angles are equal, alternate angles are equal, allied angles are supplementary. This is the statement of corresponding angles axiom. See, what are the corresponding angles in this? Angle 1 and angle 5. These are corresponding angles. See, angle 1 is equal to angle 5. And angle 2, angle 6 corresponding angles. Angle 2 is equal to angle 6. Angle 3 and angle 7. So angle 3 is equal to angle 7 and angle 4 is equal to angle 8. Angle 8. These are corresponding angles. Okay. The next, what are alternate angles? Alternate angles may be they may be alternate interior angles or alternate exterior angles. So see, alternate interior angles. Angle 4 is equal to angle 6 because these are alternate angles. So angle 4 which is equal to angle 6 and angle 3 is equal to angle 5. These are alternate interior angles and angle 1 is equal to angle 7. See, angle 1 is equal to angle 7 and angle 2 is equal to angle 8. These are alternate exterior angles. So whatever it may be, alternate interior or alternate exterior, always alternate angles are equal. And the third case is allied angles are supplementary. Allied angles are supplementary. What are allied angles? Allied angles are nothing but co-interior or co-exterior angles. So what these two are co-interior angles. They are supplementary. That is why angle 4 plus angle 5 which is equal to 180 degrees and angle 3 plus angle 6. Angle 3 plus angle 6 which is equal to 180 degrees and angle 1 plus angle 8 co-exterior angles. Those two sum is also equal to 180 degrees. Angle 2 plus angle 7 those are also supplementary. Angle 2 plus angle 7 which is also equal to 180 degrees. So if a transversal meets two parallel lines then the corresponding angles are equal and alternate angles are equal. Allied angles are supplementary. So this is the corresponding angles theorem. The next one will see what is converse of corresponding angles theorem. Converse of corresponding angles theorem. So in the corresponding angles theorem, what we have taken the first condition, the transversal must meet the two parallel lines. But in the converse of corresponding angles theorem, we take if a transversal meets, if a transversal meets two straight lines in such a way that in such a way that The corresponding angles are equal. And alternate angles are equal. And allied angles are supplementary. Then, then the two straight lines are parallel. Then the two straight lines are parallel. So, did you observe the difference? In the corresponding angles theorem, the first itself we have taken a transversal meets a parallel lines. But in the converse of corresponding theorem, what we have taken, if a transversal meets any two straight lines in such a way that, means in such a way that those two, the transversal and the angles formed by the transversal lines, follow these three conditions, like corresponding angles are equal, alternate angles are equal, allied angles are supplementary. So by satisfying these three conditions, like that, if a transversal meets a straight line, those two straight lines are parallel. So at the end we are confirming that those two straight lines are parallel because it is following these three conditions. Because of it is following these three conditions, those are calling, we are calling them as a parallel lines. So this is the converse of corresponding angles axiom. Okay, thank you.